All right, we're on question 29. It says 4 students push carts filled with sports equipment across the gym. Each student pushes with the same amount of force. Which cart has the greatest change in speed? Greatest change in speed is acceleration. Okay, acceleration is a change in speed. Could be slowing down, speeding up, turning corners, changing directions, whatever. It's always acceleration is a change in the speed. So we look at these carts, and first I guess we should look and see, is there a formula for this, because it's giving us two things. It's giving us force and acceleration, a change in speed. So what is the formula? Well, there it is, force, and there's acceleration. So force is equal to mass times acceleration, which is force is equal to mass times acceleration. So let's go ahead and write this down. Okay, but they're all pushing with the same force, so that's equivalent for all of them. So we have the masses given to us of each of these carts, and if you think about it, this is a race. Let's think about it this way. You and your buddies are in the gym. You all have these 4 carts. One of you has the very lightest, which would be the one with the least mass, right? It's the lightest, least weight. And the one with the most weight or most mass is going to be the heaviest. Now, you know, it's just like the old game with pushing the tennis ball compared to the bowling ball. Which one would be easier to push? Obviously the tennis ball. The bowling ball weighs much more. So if we're all applying the same force, we already know, if we're all applying the same force, that the lightest one is going to be the one that has the greatest change in speed, because it's going to be speeding up a lot. Now, you could have done this mathematically if you chose to. It's not necessary on this one. You just had to kind of think it through. We have the same amount of force, so we can give force a number if everybody's using the same amount. Let's say they're all using 10 newtons of force. Now we're going to plug in the mass to get the acceleration, because this is our unknown. If you wanted to do that, you want to use the formula triangle, remember? In the formula triangle, anything multiplied in the formula goes down here. Anything divided would go here. So in this formula, we have mass times acceleration, which leaves that slot here for force. All right. So if our force, we set it at 10 newtons, right? If our force is 10, and the first cart has a mass of 10 kilograms, then we're going to be moving at an acceleration of 1 meter per second squared. If we have a mass of 20 kilograms, now we have 10 divided by 20, right? We're going to plug in mass here. So we have half a meter per second squared. So this is slower than that one. That was faster. And you see it's already working out for us. Let's go straight to 25 kilograms, the heaviest one. So if we have force is 10 divided by 25, so we have 0.4 meters per second squared. Even slower, slower, slower. 1 meter per second squared is the fastest. But like I said, if you thought this through, you really did not have to use the formula at all. Our answer choice is going to be A.